Hello, my name is Muhammad Kuzaimi bin Hassan Sik, and I want to present about tool and die. Introduction. What is tool and die? Tool and die is referred to a pair of specialized tools used in manufacturing and engineering process, particularly in the production of part and component for machinery, automobiles, appliances, and various other products. Tool. A tool is an instrument or device used to perform specific function such as cutting, shaping, or forming material like metal, plastic, or wood. Tools can be hand-operated or power-operated and are designed to carry out precise tasks in manufacturing process. Die. Die is a specialized used in manufacturing to shape or form material through a process like stamping, pressing, or forging. Dies are typically custom-made and consist of hardened steel or hardened durable material. Parts of die. Die block. The die block is the main body or frame of the die. It provides structural support and houses other components. Die block are often made of hardened steel to withstand the force and pressure exerted during the manufacturing process. Cavity. The cavity is recessed area within the die block that define the shape of the finished part. Punch. The punch is the counterpart to the cavity. It is a protruding element that fits into the cavity, applying force to the material and shaping it. Die insert. These are additional components inserted into a die block to create specific feature or detail in the finished part. Die insert are interchangeable, allowing for the flexibility in the manufacturing process. Strippers. Strippers are components that help eject the finished part from the die after shaping. They prevent the material from sticking to the punch and facilitate the release of the former part. Guide pin and bushing. This component ensure proper alignment between the die block and punch, maintaining accuracy in the shaping process. Guide pin and bushing help prevent misalignment and wear on the die components. Die set. The die set refers to the complete assembly of the die component, including the die block, punch, cavity, and other necessary elements. It is the entire tool used in the manufacturing process. Die cutting operation. Die cutting is a versatile manufacturing process used to cut, shape, or form into precise shape using a die. Die design. The process began with the design of a die, which is a specialized tool featuring cutting edge, perforation, or other shaping elements. The die is typically made of hardened steel or other durable material. Material preparation. The material to be cut is placed on a flat surface, often referred to as cutting bed. The material can be sheet or roll, depending on the specific requirement of the manufacturing process. Positioning. The die is carefully laid over the material, ensuring that it is positioned correctly to cut or shape the material according to the desired design. Pressing or stamping. The die is pressed down onto the material with significant force. This can be done manually for smaller scale operation or through the use of mechanical, hydraulic, pneumatic press for larger scale and automatic process. Cutting or shaping. The cutting edge of the die penetrates the material, cutting into the desired shape or form. The shape of the die corresponds to the final product or compound required. The last one is injection. After the cutting or shaping is complete, the die is lifted and the excess material is injected. Depending on the complexity of the die and the material being used, there may be additional mechanisms such as strippers to assist in the injection of the cut part. Fundamental of die or cutting operation. Plain banking. This process involves cutting out simple, straightforward shape from a sheet of material. The die is used to cut the outline of the shape without any additional features or details. Piercing. Piercing involves creating holes or perforation in the material. Dies used in a piercing have sharp edge that punch through the material, creating precise holes or perforation as required. Lancing. Similar to piercing, lancing involves creating slots or narrow opening in the material. The die used for lancing has a specific design to cut elevated or narrow shape. allowing for the creation of slot or opening. Cutting off and parting. This operation involves cutting a part section away from the main material. The die is designed to cut through material completely, separating the desired part from the rest. Notching. Notching is the process of cutting of small V-shape or U-shape section from the edge or surface of the material. This technique is used for various purposes such as creating tabs for easier assembly or enhancing the flexibility of the material. Shaving. Shaving involves removing thin layers of material from the surface. The die used for shaving is designed to scrape away a small amount of material, achieving precise thickness reduction or surface finishing. Trimming. Trimming is the process of cutting excess unwanted material from the edge or perimeter of workpiece. This technique helps refine the shape and size of final product, ensuring clean and precise edge. This die cutting operation can be applied across different industry and material, providing efficient and precise manufacturing solution for various product and application. The choice of technique depends on the specific requirement of the project and material being processed. The cutting action in punch and die operation. Alignment. Proper alignment of the punch and die is crucial to ensure accurate cutting. The workpiece is positioned on the die precisely under the punch. Application of force. The punch is then brought down onto the workpiece with significant force. This force could be applied through various means such as manual hydraulic or mechanical press, depending on the scale of the operation and the material being cut. Penetration and shearing. As the punch is then onto the workpiece, it penetrates into the material. The edge of the punch comes into contact with the material along the contour of the die, resulting in shearing or cutting of the material along the desired shape outline. Material removal. The portion of the material within the perimeter of the punch cutting edge is removed from the larger workpiece. This creates the desired shape or cut out. Clearance. Once the cutting action is complete, the punch is retracted and the finished part of or cutout is removed from the die. Proper clearance between the punch and die is important to ensure smooth extraction of the finished piece without distortion or damage. The cutting action in the punch and die operation relies on precision, the ability of the punch cutting edge to shear through the material effectively. This process is used in various manufacturing industries for production product, component and product with specific shape and dimension. The punch and die method allows for high repeatability and accuracy in mass production process. Relation between the die clearance with cutting action in punch and die operation. Material deformation. The die clearance affect the degree of material deformation during the cutting process. A smaller die clearance tends to result in more significant deformation, while a larger clearance may lead to less material distortion. The choice of die clearance depends on the material properties and the desired outcome. Shearing action. The die clearance is designed to facilitate the shearing action between the punch and die. A proper clearance allows the material to be sheared clearly. Producing and precise cuts to type of a clearance might cause excessive wear on the tools and result in a more challenging cutting action. Tool wear and durability. Die clearance plays a role in tool wear and the overall durability of the punch and die. Insufficient clearance can lead to increased friction and wear on the cutting edge, affecting the longevity of the tools. On the other hand, excessive clearance may reduce wear but could compromise the quality of the cut. Types of dies. First is blanking dies. Function. Blanking dies used to cut flat piece or blank from sheet metal. The process involves the removal of a specific geometric shape from a larger sheet, leaving the desired part. Piercing dies. Function. Piercing dies are designed to create holes or perforation in a workpiece without removing material around the holes. This type of die is often used for creating opening in the sheet metal. Bending die. Bending die are employed to bend sheet metal or other material to a specific angle or shape. The die facilitates the deformation of the material into the desired without the cutting. Forming die. Forming die shape a workpiece into a specific form without removing material. This type of die is commonly used in process where the material is reshaped and deformed into a desired contour. Complete the die design. Die block. Function. The die block serves as the main structural component of the die assembly. It provides stability and support for other die components. Usage. Die block are used in various manufacturing processes to house components such as the cavity, punch, and other features necessary for cutting or forming material. Number 2 is punch and punch plate. Punch function. The punch apply force the material, causing cutting, shaping, or forming. Punch plate function. The punch plate holds and support the punch during the die cutting operation, ensuring proper alignment and stability. Usage. These components are essential in die cutting process across industry, including sheet metal fabrication and stamping. Pilot, strippers, and pressure pad. Pilot function provide guidance and alignment for the workpiece, ensuring accurate positioning. Strippers function assist in ejecting the finished part from the die after shaping, preventing material sticking to the punch. Pressure pad function to pressure pad control the material during the die cutting process, applying pressure as needed. Usage. These components are vital in maintaining precision, and efficiency in the die operation, preventing misalignment and facilitating material handling. Force mechanism involved in die operation. Function. The force mechanism often provided by a press applies the necessary force to the punch, allowing it to interact with the die and shape or cut the material. Usage. Mechanical, hydraulic, or pneumatic press are employed in various manufacturing processes for die cutting operation. Perform 3D design of blanking dies. This is my design for a blanking part. A blanking die of the blanking part, which is upper and lower, middle and stripper. Here are the key component and aspect of a blanking die. First is die block. The die block is the main body or frame of the blanking die. It provides structural support and house other components such as the punch and the cavity. Punch. The punch is a component of the blanking die that exerts force onto the material, causing it to be cut or sheared. The punch typically has a shape corresponding to the desired part. Cavity. The cavity is recessed area within the die block where the material is placed before the blanking process. It defines the shape of the blank that will be cut from the material. Clearance. Clearance is the intentional space between the punch and the die cavity. It allows for proper shearing action and helps prevent excessive wear on the tools. Strippers. Strippers are components that assist in ejecting the cutting material from the die after blanking process is complete. They prevent the material from sticking to the punch. Blanking process. The material, typically a sheet or strip of metal, is placed over the die cavity. The punch is set, applying force to the material, ensuring it along the edge of the die cavity. It's the detailed drawing of the blanking die. It's the assembly of the blanking die. The next sustainable element to increase tool life and awareness of environment. First is material selection. Choosing durable and high quality material for die component is crucial. Opting for material with longer lifespan such as high-grade steel or carbide increase the durability and longevity of the dies, reducing the frequency of replacement and waste generation. Optimize dies geometry and cooling. Designing dies with optimized geometry and incorporating efficient cooling channel or system help manage heat effectively. Proper heat management extends tool life by reducing thermal stress and wear on the die components. 3 is surface treatment and coating. Utilizing environmentally friendly surface treatment and coating such as lead drilling or PVD, physical vapor deposition. Coating enhances the wear resistance of the die surface. This not only extends to life but also reduces the need for frequent replacement. Discussion. First is material selection. The problem is selecting the right material for the die component is crucial. Choosing a material with insufficient hardness or wear resistance can lead to premature wear, reduced tool and die. The solution is conduct through material analysis considering factors like hardness, toughness, and heat resistance. Choose material such as high-speed steel or carbide based on the specific requirement of a blocking operation. 2 is clearance optimization. The problem is inadequate or excessive clearance between the punch and die cavity can result in pore shearing, but formation or increasing wear. The solution is optimize the clearance based on the material properties, thickness, and desired edge quality. Conduct testing and analysis to determine the optimal clearance for the specific blanking application. Conclusion. In conclusion, tool and die designing is a specialized field that plays a pivotal role in modern manufacturing. Well-designed tools and die are integral to achieving high quality, consistent, and cost-effective production of various components and products across industry, contributing significantly to the success of manufacturing operations. As technology advances and design methodologies evolve, the efficiency and capabilities of tool and die design continue to improve, driving innovation and progress in manufacturing process. Okay, that's all from me.